Hi everyone, my name is Jordan Uyeki and I am a current Master's in Data Science student at the University of San Francisco. Today I'm going to be talking about my final project for my machine learning class. For my project, I aim to build a machine learning classifier model to predict the outcome for animals in the rescue and shelter systems. So the basic premise behind this project is to try to identify factors that contribute to positive outcomes such as adoption for rescue and shelter animals. According to the American Society for the Prevention of Cruelty to Animals, or the ASPCA, over 1.5 million animals are euthanized each year. Now, I know that the systems are often over capacity, but I still feel that this number can be lowered. I was interested to see if just having a better profile can improve the chances of adoption. For example, consider these two profiles. I think most people would agree that the one on the left would be more appealing to a family looking to adopt. Now, I may be a little biased because that is actually the picture that was posted on my puppy's adoption profile. So this is my dog Bolt. He is about 10 months old now, and we adopted him from a rescue last August. Anyone who was adopted during COVID can probably agree that adoption inquiries have been unusually high recently. Because of that, I spent hours scrolling through different rescue and shelter sites during my search for Bolt. Throughout my search, I definitely came across a lot of profiles that were lacking in information. I often found myself overlooking profiles with no photos or very sparse bios. While some of these details, such as age and health, can't be helped, things such as having a name listed or having higher quality pictures available, or in this case, at least having pictures, would definitely improve the appeal of an adoption profile. So now about the data. For my project, I analyzed the Austin Animal Shelter Outcomes dataset, which is publicly available on Kaggle. This dataset contains information on over 70,000 animals with 12 different columns. The original data contains information on various types of animals, including very random types such as livestock. For the purpose of this project, I chose to just focus on the dogs and cats in the dataset. After filtering, I still had over 50,000 animals for my model. So my target variable was the shelter outcome, which included various possible values such as adoption, transfer, and euthanasia. I chose to leverage 6 of the available features for my model. So age is the age of the animal when they were listed on the adoption sites. Month year is when the animal was listed on the site. For this, I chose to extract just the month to see if the time of year impacts the chances of adoption. For example, I felt that adoption rates might be higher around the holidays. Animal type just represents the type of animal, whether it's a dog or a cat. Name represents whether or not the animal has a name. For this, I had to binary encode this. I just chose to make it yes if the animal had a name or no if they did not. Fixed status represents whether or not the animal has been spayed or neutered, and gender represents if the animal is a male or a female. So here is a basic overview of my process. I first had to prepare the data by cleaning it and performing some EDA to get an intuition about feature importance. And then I performed some feature engineering on my chosen feature columns, as I previously mentioned. Next, I utilized sklearn's randomized cross-validation search to find the optimal classifier model and its hyperparameters. And lastly, I fit my final model and evaluated using the accuracy and F1 score evaluation metrics. So for my search, I decided to compare 3 different classifier models: the random forest classifier, the ridge classifier, and the multi-class logistic regression. I passed them through sklearn's randomized search CV function and also included a grid search for the optimal hyperparameters of each model. And on the right, you can see the final model choice of the cross-validation search. So my final model was the random forest classifier with these non-default parameters. So a maximum depth of 10, a 4 sample minimum per leaf, and a 4 sample minimum per split. So once I had my final model, I fit it on the training data and evaluated its performance via the accuracy score, which is a measure of the proportion of correctly classified outcomes, and the F1 score, which is a measure of the model's precision and robustness. So first, looking at the test data values, the accuracy score indicates that the model is able to correctly classify the animal's outcome 77.5% of the time. However, the F1 score indicates that the model is not as precise as we would want. I will discuss potential improvements to this later in the presentation. I also chose to calculate the evaluation metrics of the model on the training set. We can see that for both the accuracy score and the F1 score, the training data metric is only slightly better than the testing data metric, which validates the generality of the model. Here are some things that I would like to improve on in future iterations of this project. One thing is that I would like to be able to incorporate other variables in my model. For example, this dataset contained a breed and a color variable. Since this data is manually inputted, there were way too many unique values to include in the model, which made me worried about the risk of having unseen values in the test set. To overcome this, I would like to look into more complex feature engineering methods. I would also like to do some more feature importance analysis. Like I previously mentioned, I did do EDA to get an intuition about the various feature importances, but I would also like to leverage something like sklearn's permutation importance functionality to automate this process and be more robust in feature selection. Lastly, I would want to consider recoding the target variable to have less specific target classes, which I feel would help improve the model's evaluation metrics. I might try making this a binary classification model where I only have two possible values, a positive or a negative outcome. This would avoid, for example, the outcome of died to be misclassified as euthanasia, which would be pulling down the evaluation metrics in my current model. In summary, with improvements, I feel that this model could be very useful in the animal welfare sectors. It could be useful to help shelter animal and rescue workers and volunteers optimize animal adoption profiles to give these animals the best chance of finding forever families. And that concludes my presentation. Thank you for listening.